Hey, what units did you get on the homework? I'm gonna try to redo this, but I got degrees Celsius per radian kilometer. Welcome to Curly Carbocation. Please subscribe and stay tuned. Something I explained in one of my other videos was a unit logic check. Essentially, before plugging in the numbers, do all the operations to the units first to make sure that the units match at the very end. This method always worked for me in college, and it was kind of like a little cheat that all my friends and I had. In my first video, I explained that I'm gonna use enthalpy and the ideal gas law, but for this video, we'll do the ideal gas law. While most videos would use an example, I'm going to explain the mechanics of this problem. Shut up all you vocab nerds, I know that mechanics isn't the right word. Let's say you're tasked with finding the volume. First things first, write down the equation. I'm going to be one of your sneaky professors, and I'm not going to use the R value that has volume in it, but energy. So the R value is going to be 8.314 joules per mole Kelvin, but that is also equal to 8.314 meters cubed pascals per mole Kelvin. Joules is energy, meters cubed is volume, and pascal is pressure. Wait, so does that mean that the PV side of the ideal gas law is energy? I don't care right now, we're solving for volume, don't get distracted. Keeping that 8.314 joules per mole Kelvin in mind, let's rearrange the equation so that we get volume. So PV equals nRT turns into V equals nRT over P because we divided both sides by P. Now that volume is isolated, let's make sure with the other units that we can actually produce volume from that equation. So with volume equaling nRT over P, that has units of moles times joules per mole Kelvin times Kelvin all over pascals. This R value is going to be the trickiest, so let me show you my long way that actually helps me out. Let's just consider this entire numerator as one thing. Anything divided by 1 is itself. Clary, everyone already understands how to do the algebra. No, they don't. Shut up or swipe away. All numerators are multiplied together and all denominators are multiplied together, but not that one. That mole dash Kelvin is not really a mole minus Kelvin, it's a mole times Kelvin. But now that we've got this, we can start canceling things out. Hey, look, moles, Kelvin, and then 1 times 1 is just 1. Now we're left with joules over 1 over pascals. 1 is a tricky number because it conceals the movement of variables, so I'm going to do this the long way again. Pascals is by itself in the denominator, so I've made that pascal over 1. Numerator stays the same, that's going to be J over 1. The reciprocal of pascal over 1 is 1 over pascals. Those cancel out, and we got joules over pascals. Joules over pascals is not a wrong answer, but it's not the one we're looking for. Remember, we're looking for volume, and the reader is expecting something that is obviously volume. Can someone remind me what a joule and a pascal is? That's right, a joule is a Newton meter, and a pascal is a Newton per meter squared. Energy is force times distance, and pressure is force over area. Dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to make that Newton meter over 1 divided by Newton per meter squared. So the reciprocal of the denominator, Newton per meter squared, is going to be meters squared per Newton. Hey, look at that. Newtons cancel out. And now we are left with meters cubed over 1 or just meters cubed. So yes, the answer does get us volume. If this video helped you, please give me a like and I will see you next time. Bye!